Good day to all. My name is Petra Zoric, and today I will present you a paper entitled Information Service for the Visually Impaired Persons in Public Transport, MAppIN, which I wrote with my co-authors Marko Perisa and Valentina Anic. First of all, I will say something brief about myself. I'm currently employed as an assistant at the University of Zagreb, Faculty of Transport and Traffic Sciences at the Department of Information and Communication Traffic. I'm also a PhD student and I'm developing my knowledge in the laboratory of security and forensic analysis of information communication systems, which is part of the mentioned department. My scientific work is focused on researching the possibility of applying information and communication services in different segments of the transport system. I also had a role in organizing this year's conference as a publicity and social media chair. On this slide, you can take a look at the research overview, but I will not dwell on it too much due to the time constraints I have to present our work to you. For the purpose of this research, we did user needs analysis to define functionalities of mobile application solution MAppIN. We proposed the conceptual architecture of the service delivery system and accompanied functionality development of the MAppIN mobile application. And for the last, we have some conclusion, and I will tell you what we concluded. Visually impaired persons face several problems and challenges when use public transport services, such as waiting at the wrong stop, not being informed about the timetable, getting into the wrong vehicle, information in vehicles, and more. Visually impaired persons differ in their characteristics and specific requirements, so it has to be considered when developing new information and communication services and solutions. Currently available literature in the development of systems and services for informing users when moving the traffic network is focused on developing mobile application solutions for vehicle identification and user navigation services. In the Republic of Croatia, mobile applications are on the market of operators providers of urban public passenger transport, such as Z-Info and HŽPP Planner. The disadvantages of these mobile applications are that there is no single solution for the user regardless of the traffic mode that needs to be used: bus, tram, train, or taxi. The introduction of sensor networks enabled real-time communication between devices and large amounts of data collection. In parallel, we have presented the concept of Society 5.0, which aims to enable the personalization of products and services according to the wishes of end users. This paper aims to investigate the needs of visually impaired users who use the public transport system and define the functionalities of the user information service. The purpose of using such a service is to raise users' quality of life to whom all relevant information is delivered in real time via mobile application solution. Blind and partially sighted persons face various problems when using public transport services, such as inability to identify a point of view due to lack of signs, inability to identify the vehicle at the stop, or lack of timetable at stops that are legible to visually impaired persons. In order to collect data on the satisfaction and attitude of visually impaired persons about the solutions and services implemented so far in the city of Zagreb, we conducted a survey. We found out that visually impaired persons are dissatisfied, which indicate the need to improve existing solutions or develop and implement new solutions and services. In cooperation with the Up-to-Date Association, we collected 27 answers from the 22 blind and 5 partially sighted persons, and persons using public transport services are of different age groups. Some of the results we received from the respondents is that most of them mainly use trams and buses as a means of transport, and the majority want to receive audio information on their mobile devices. Also, the majority of respondents, 63% of them, expressed a desire for the possibility of buying tickets via the mobile application because they consider it is safe to conduct money transactions via the internet, and it would also facilitate the whole process of buying tickets. But we wanted to present the most important graph on this slide. Obtaining specific feedback from persons with visual impairments is of great importance in order to be able to orientate and create their image of traffic and the environment, which can be seen according to the results on this slide. It is necessary to enable users to receive feedback in a form that will be accessible to them. A large number of visually impaired and blind persons use public transport services every day, and it is necessary to present new opportunities for information services and develop a solution that satisfactorily meets the needs and requirements of them. Based on the results, we identified their needs. For example, the functionality informing on arrival at the stop is categorized as one of the most important according to users' needs. To enable this functionality, the stops must be equipped with Bluetooth beacon technology, which provides all the information on arriving at the stop or train line or place of entry into the vehicle. Upon the vehicle's arrival at a defined stop, the user receives information about the line and direction of movement. Based on this information, the user decides whether he wants to get into the vehicle or not. If the user has given an affirmative answer, navigating to the vehicle door begins by monitoring beeps or vibrations. If the user has decided not to enter the vehicle, he will receive information about the arrival of the following vehicle at the stop. Conceptual system architecture is based on the cloud computing for the blind concept and beacon technology. The work of the proposed architecture is based on the information as a service model, where the service provider, users, and other participants are authorized to update and store new information. The information is distributed to end users through the software as a service model via mobile application or web browser, and to other participants who develop applications through the platform as a service model. The cloud architecture consists of databases for managing information about users and public transport service providers. A visually impaired person can access specific data stored in the cloud using a mobile application installed on their device. Machine-to-machine communication occurs between the vehicle and the mobile terminal device, while machine-to-human communication occurs between the mobile device and the user. The Bluetooth beacon is placed above the vehicle door so that audible signs towards the door can guide the user. In addition to the GPS module, tram, bus, or rail vehicles implement a counter of persons according to whose data the user will decide whether to enter the vehicle or not. The data collected by the sensors installed in the vehicle are sent to the cloud via the internet, where they are stored and processed using machine-to-machine communication. Based on data from the cloud, the user is then provided with feedback in a customized form via machine-to-human communication. Communication to the electronic or mobile service provider is performed via 3G, 4G, or 5G mobile networks. The user accesses the service using a mobile MAppIN application and a mobile network. MAppIN is a mobile information and navigation application designed for blind and partially sighted users. We created a test environment to check the operation of certain functionalities of the MAppIN application through the MIT App Inventor software. The main menu consists of 4 links and, depending on the selection, data from a specific traffic area is displayed. Changes in traffic include information on accidents that have occurred, which interfere with the planned flow of traffic, and include information on the organization of emergency transport. The user can view the information in an additional menu, but can also be informed at any time via a pop-up notification that appears on the screen. The list of all stops where the selected tram stops and the vehicle's arrival time at the stop is displayed after selecting a specific line. After activating the navigation button, the user confirms the start of navigation and routing to the defined location. When the user selects the option to purchase a ticket, a new window opens. If all entered data are correct and funds are taken, the user is informed that the payment has been successfully made via pop-up notification. Confirmation of the purchase tickets can later be found in the other menu if the ticket controller requires the person to show it. To conclude, today's development of innovative solutions and services and their application in the Society 5.0 environment makes it possible to contribute to a sustainable social ecosystem. The proposed conceptual architecture of the system, based on modern information and communication technologies, aims to provide real-time information to users who move through the transport network and use the public transport system. With accurate information, it is possible to raise the quality of life and equal integration in the society in which the user is located. It is important to apply the basic principles of universal design when proposing the system architecture. The authors will focus on other technologies and frameworks of Society 5.0 environment for greater integration of the persons with disabilities in society in future research. Thank you for your attention. I hope this presentation was interesting to you. Please Feel free to contact my co-authors or me about this topic. There are our official links where you can find all information of our work at the department and faculty and our contact details. Of course, we are open for new ideas, collaboration, and suggestions for our future work, and enjoy in the rest of the conference.